Hi there, guys. Well, today we're going to talk about the OLED display. I actually went ahead and bought two of these on eBay. They are 0.96 inches, 164 times 32. I can't remember. It's not that important, but it's times 64. That's it. 164 times 64. And let's see if the camera can focus on this little thing. Oh, I don't know what that red dot is, but there we go. Don't mind the big green circuit on the back. That's just because I have it stuck on a small piece of foam. So to protect the pins, that's all. And I dropped it. Nice protection. Well, we can check it out afterwards. What I really wanted to show you is this setup right here. And it's just hooked up to my Arduino. And as usual, I will take my trusty GoPro camera, which is not that great to record indoor because I think it has to do something with the hertz. My light here in Europe is 50 hertz. So whenever I record with this indoor, I get a lot of sort of static. Okay, let's see if we can focus again. No. Well, I'm sure it eventually will. Let's just... Maybe it won't. Who cares? Anyway, I used the adafruit libraries to get the OLED screen to work, and was quite successful in doing that. And that's what we're going to... Yeah, that's just me turning off the web camera to try to make it work. There we go. So, first of all, let's take a look at some of the code. That's big. Here we go. As usual, there's nothing special except to run it, you need to include... Well, the first part here is actually from the Adafruit example. And once you install the Adafruit libraries, you can just Google these two. You need both of them, the gfx.h and the ssd1306.h. Both of these libraries are needed, and once you have them, you just copy them right into the libraries folder. You can see I got the two folders right there. And when you get them from GitHub, they are usually named underscore or something master. Just remove that master part. Anyway, the first part comes with the example that comes with the driver. Sorry, library, as you can see. And the one I used to get this going was this one, the third one, called 128 times 64 I squared 2 or I2C. It doesn't really say squared, but I think they meant to say that. That's the communication library used by sorry about that, by this small OLED. And when you look at the bottom, it's very hard. Let's do this. You can see there's 4 pins. And if we do this, I'm not sure if it's too dark, but you can see it has one type of layout. And I have noticed something from other YouTubers that depending on who the supplier is, they may actually have a different layout. And that is quite strange. However, to get this to work with the libraries included in the adafruit, you need to change the address. And the address you need to change is a bit down in the setup loop. There's this one called display begin, calls the library, and the address is by default named D, like this. So this part I've highlighted right there is the one you need to change. So in order for me to get it to work was to change the OX3D to OX3C. And then it worked. And my program is very simple. First of all, I just wanted it to test out the screen. And I wanted to make it so I could change the output on the screen. So that's why there is you can hear it, a small button on my circuit. And most of what I have done till this part is just declaring ints, integers, booleans, different variables needed. I've declared which pin modes on the Arduino is in and out. And I also declared a pin mode and a write for some RGB LEDs I have bought. Well, and these are shit, because usually I would buy cathodes, and the ones I've got this time are actually anodes. So that means the longer leg is actually a voltage input, and you drain voltage from the one you want to light up. So it's actually opposite of any other. Well, it's actually opposite of those called cathodes, which are the one I usually use because it makes more sense to me just to have the grounded one and send a wired signal to the one I want to light up. So it took some time, but I had to inverse my code. I could also inverse it on my board, but that would include me setting up a few MOSFETs, actually one per color. And I didn't feel like doing that, mostly because I only have 2 extra MOSFETs laying around, so kind of a no-brainer. So that's why you see me setting the red, green, and blue pin to 255. That's just to turn the line LED off, because it's opposite. Okay, and all I'm doing in the setup is first printing well, that's Danish, sorry about that, but it says welcome, and then a main display. That's just 2 functions I've made that actually shows something on the OLED, and we'll get to them in a second. The main loop contains nothing but a detector for the button. We have a switch state which reads the button, and we check if it's pressed. And when it's pressed, we're just going to change a number to a variable called menu state. And since I have 3 menus for my OLED, I have 3 numbers. So when you press, you switch to the next one. When you press again, you switch to the third one, and then start over. That's all that's being done here. And this one, I'm keeping the RGB anode LED on at a very small, you can see it's 255, 254, and 255, so a very small green. However, I actually think it's quite bright. Yeah. Anyway, then I'm going to show the menu from menu state. That actually means we're going to switch menus depending on what number. That's just a case select. You can see it right here. That's this function. So if it's menu state 1, it's going to jump into this one and show main display. If it's menu state 2, then it's going to jump in and show temperature display. Menu state 3, it's going to show light display. Sorry, it's actually 0, 1, and 2. That's it. That's the main loop. Just stands here, nothing else. Then we have the menus. I'm just going to separate them a bit so we don't get them mixed up. Well, the first one is this one called light display. I'm actually not using it anymore. And you can see I just have question marks here. But you'll see it in a bit on the OLED screen how it actually looks when I use it. Another thing is the OLED screens I got are 2 colors. And the first 1 or 2 line, depending on how big letters you're writing, is yellow. Then the rest of the OLED is blue. That's quite cool. I think it's a cool color setup. However, you can't change from blue in the yellow text and vice versa. It's just white and black when you program it. That's what you can see in the code here. You can see set text size, set text color, kind of a giveaway what they do. Set the cursor position to 0, 0 and type in, well, that's just my name and a menu title. Type in anything. And if you do this with set text color, comma, black, that's actually the background, because you could inverse them if you want, so you could write on a black text on a colored background. Whatever you find funny. And then I just have a line of question marks. That's basically just because I'm not using the menu anymore. This is just a function that reads the light sensor. That's all. This one is the second menu. That's the temperature display. Let's move this one down. And this function is basically just reading the temperature sensor and converting it into Celsius. So, just like before, the first part sets up the top menu, the yellow part, and this part makes up the menu below that. And you can see I got this one called temperature Celsius, and I'm actually printing in the temperature. And I'm just calling this function for light and this function for, sorry about that, for temperature. That's it. This thing down here is not in use. That's just me testing. I want to write random text to the screen. This one, however, that's the main display. Whenever I initialize or click through to the menu 0, that's this one being shown. It's not really showing anything except the name, what kind of software this is, who made it. Well, that's me. Then I also have this one, the first one being shown while it's starting up. It's actually just saying booting done on the menu. Because there can be a delay. Then there's another thing I haven't mentioned. In the main loop, I have a delay of 250 right here. And that's just to prevent the bouncing button. You know, the buttons will keep pressing themselves, or the computer will read it as such. It's prevented by doing this. However, that means sometimes it actually misses me clicking. So sometimes I click, it doesn't work. So the way this one works is you hold the button until the LED turns in color. That's actually what this one does. So whenever I press the button, it turns from green to blue. And you just let go, then it switches. You could also just keep holding the button and switch through all the menus. So that's what we want to go through now. So well, first of all, I'm going to plug in the Arduino to the USB. There we go. Wonderful sound. And then I'm going to start my camera. And as you know, I can't see what the camera is doing. So hopefully I'm capturing the most of it. You can see we have the OLED right here. Right here where I'm pointing now is the light sensor. The temperature sensor is right there, and the green RGB LED. So whenever I press this button and wait for the light to turn blue, the menu switches. You can see it shows the temperature and it shows the light value. And you can actually see it's updating. So if I were to let's zoom in a bit, hold my finger on the temperature sensor, you can see it's rising to 19, 20, sort of. Let's see if I can get a good grip. There we go. 20, 21. Come on. 22. And when I let it go, it should drop down again. The same with the light sensor. You can see it's right there in front of my finger. I'm now going to cover it up. There we go. 1. So that means I'm actually able to update things on my menu live. And if we take a look, that's because I'm calling this menu state over and over again in the main loop with a 1/4 of a second's delay. Now, if I press the button until the blue light, there we go, I get the question line. So that was this one we have right here. And you can see I still have the same menu. Again, we get to the front menu. Again. And if I hold it, it should just switch between them. There we go. So that's actually pretty cool. That means I'm able to incorporate a small LED OLED screen into a control unit or control box. I think I have one. I had one, but now it's gone. Oh well. Well, I was working on a small box for the Arduino, and it's sort of a mounting box for. Let me just take a look. Well, something like this. Except this one was a real box meant for electrical installations. And I don't know if I have actually mentioned it online yet, but I'm building a automated system for my greenhouse. Yeah, I mentioned it in the do-it-yourself skater video. And that means I'm going to have a Arduino or possible 2 controlling watering, fertilizing, temperature, air, and what else is there to control? And what would be nice if I added a small switch so I can turn the small screen on like this, and then be able to inside the greenhouse actually see what's going on, what's the current moisture of my dirt, my ground. I actually have these, I don't know, and it's basically just a 2 wires on some PCP and a potentiometer and a few resistors and a octocoupler. I don't know why it's on there, but it's there. And if I maybe think it should need water, I would be able to just press a button and it should start watering, even though the computer or the Arduino would say it's outside the calibration and watering is not necessary. There should always be an option for a user override, and I would like that option to be present on the actual box. And it annoys me a bit. I can't find the box because, well, maybe I put it somewhere else, obviously. But the point is, the box needs to be waterproof and sealed, just like you would any electrical installation. And yeah, I can't stop looking. Oh, spare parts. And oh, there we go. There we go. It was hiding. Here we go. This sort of box. And this box is great. You can see I've already made a hole, a very crude hole. This is just a test box. But it actually fits a Arduino. And I got some small PCBs that can stay on top of the Arduino. And they work just like shields, except they are not shields. So let's see. There we go. Copper plates from China, of course. And they also fit perfectly in here, so I can make my circuit on top of this and then take my small OLED display, get it mounted inside from this side so it sticks out, and a few buttons on the side so you can interact with the Arduino on site. Of course, you also will be able to interact with the Arduino from our house, which is going to be controlled via SCADA. And I plan to do that via a wired connection. I don't think Wi-Fi is a good idea because I'm trying to save power down there. So, wired connection, SCADA, and local control as well. But I want to be able to turn the OLED off when it's not used. So a switch button to turn it on, and then 2 buttons to interact with the actual Arduino on site without any program. That's my plan with the OLED screens. And it seems to be working. I've done some testing. And I'm going to use the same setup as we talked about in this video with the menus. Except I'm going to have different menus. This is just a test setup with different sensors. If you have any questions, comments, requests, please let me know. Thanks for watching, and I'll see you next time. Bye.